Now we're going to get into slightly more complicated examples, and honestly they're really not that more difficult than what we did in the previous example. So what we have here, we have negative 16 times 10 6 to the x equals negative 80. So we got to solve for x. So I need to bring this exponent down somehow. So we're going to do log of both sides. Now before we do, let's clean this up a bit. Let's move the 16 to the other side. So I'm going to divide by negative 16. And I'll be left with 10 to the 6x equals, I don't know this off the top of my head, 80 divided by 16 is 5. So now what do? We're going to go ahead and take log, and they want us to use log base 10, which is just regular log. Yeah, let me get rid of the parentheses. And so if you remember, the reason why we're doing the log is because we can bring down the exponent. Oops, I missed that one. It allows us to bring the exponent down, which we need to in order to solve for x. So in the next step, we're going to have 6x log of 10 equals log of 5. And what is log of 10? So log of 10, well, 10 to what power is 10? Well, 10 to the 1 power is 10, right? So log of 10 is just 1. And then to solve for x, we divide by 6. And x equals log of 5 divided by 6. So that's going to be the first answer right here. Solve the equation for x, express it as a logarithm base 10. Here's the answer. That's the log base 10 of 5 over 6 would be what you put there. What do you put for the second part of the answer? Well, that's just going to go into Desmos. So you have log of 5 divided by 6. And that's 0.11. It says round to the nearest thousandth, so 0.116. And there you go.